The next problem of module 1 is question number 6. An architect drew the sketch below while designing a house roof. The dimensions shown are for the interior of the triangle. We are given a triangle ABC, which is the pattern of the roof. AB is equal to 24 and BC equal to 32. Even though we are not given AC, it can very easily be found that AC is also going to be equal to 24 because we are given that both the base angles are x, which means that it is an isosceles triangle. Now, to find the value of cos x, we have to use either cosine formula or by taking the property of an isosceles triangle. So, by the method 1, if the student is aware of the cosine formula, we can go ahead as cos x is equal to 24 square plus 32 square minus 24 square divided by 2 times 24 into 32. This is based on the formula cos A equal to, or cos B, since we are having B there, cos B is equal to A square plus C square minus B square by 2AC. Using the above formula, what I am getting is 24 square gets cancelled off up and down, 32 square 132 cancels, I am left with 132, which now cancels with this and I get it as 16 by 24, which reduces to 2 by 3. So, the value of cos x is 2 by 3. So, if the student is aware of the cos B formula or cos A formula, the cosine rule, then this can be made use of. If that is not possible, if the student is not aware of that formula, I am going to do it by a different method. That is, I am going to drop a perpendicular from A to BC, let it go and fall at D. And since ABC is an isosceles triangle, the altitude from the vertex should bisect the base. Therefore, BD has to be equal to half of 32, which is 16. So, I get BD equal to 16. So, making use of cos x for triangle ADC, I am going to have it as cos x is equal to 16 by 24, which also reduces to 2 by 3. So, the method cos x equal to A square plus C square minus B square by 2AC can be done if the student is aware of the cos formula, or if the student is not aware of it, the basic property of an isosceles triangle can be used. Now, let me see what is the next problem. I have to clear this off. Going to the next one, that is 7th problem of module 1. The function f is defined by f of x is equal to 2x cubed plus 3x square plus cx plus 8, where c is a constant. Where c is a constant, and in the xy plane the graph of f intersects the x axis at the points minus 4 comma 0, half comma 0 and p comma 0. Obviously, it will have maximum 3 points of intersection with the x axis because this is a third degree polynomial. Let me give names for these points as A, B, C. The question is, what is C? The answer options given are A is 18, B is minus 18, C is 12 and D is 10. Okay, to solve for C, I can make use of any of these points to substitute, that is minus 4 comma 0 can be substituted in the equation of f of x because it passes through that point. Taking f of x 2x cubed, it is not 12, I am sorry, it is 2x cubed plus 3x square plus cx plus 8. Plugging in the place of x as minus 4, I will be getting 2 times minus 4 the whole cubed plus 3 times minus 4 the whole square plus c into minus 4 plus 8 equal to 0. That gives me minus 64 into 2, which is minus 128 plus 16 into 3 which is 48 minus 4c plus 8 equal to 0, which gives minus 128, and 48 plus 8 56. I am going to subtract from that. 8 minus 6 is 2 and 11 minus 5 is 7, but since the greater number is having a negative sign, I still have to retain the negative sign, which leads to minus 4c minus 72 equal to 0, or 4c equal to minus 72, c equal to minus 18. Hence, the right option is B.